Yes. So in name reactions we discussed with a selective managed reaction followed by Michael addition, Robinson annulation. After Robinson annulation we also discussed reformats reaction. So at last after reformats reaction Shapiro, SN-Moser, etc. Okay. So conversion of tosyl hydrogens to olefin is called Shapiro reaction. So if you want to do any epoxidation, alpha comma beta epoxy, and this is a starting material used in SN-Moser Tanabe fragmentation. So what is the answer? So select alpha, beta, and this is target carbon. So here you need to put triple bond, and here you need to insert carbonyl. So this is SN-Moser Tanabe fragmentation. Okay. Next reaction. Darzens glyceric ester condensation. Darzens glyceric ester condensation, also called Darzens reaction. Darzens glyceric ester condensation. So it is most important one, especially for 2 marks. You can expect straight forward from this one. Why? Because one miscellaneous point is there which cannot be observed in other reactions. So that is a specialty of this one. Darzens glyceric ester condensations. C. You write this. Alpha halo esters reacts with aldehydes or ketones. In presence of alkali medium, that is base. In presence of alkali, to give what is final answer? Here key product is alpha comma beta epoxy ester. This is called glyceric ester. This molecule name you need to remember. It is called glyceric ester. Which among the following is glyceric ester? This point they asked many times in exam. Okay, so in part C, one of the interconversion, exactly in middle of the reaction, you may expect this word. Also helps in carbohydrates even. Glyceric ester condensation. Here I am taking alpha halo ester. Molecule should carry alpha halogen. It is reacting with a carbonyl compound in presence of base. What is final answer? That is glyceric ester. Here structure of glyceric ester is very important. So what is glyceric ester? Alpha comma beta epoxy ester is called glyceric ester. Like this you need to remember every name reaction while you are preparing any short notes. You need to remember what is the major area you need to stress. So don't prepare like alpha comma beta epoxy ester. First you prepare in the form of glyceric ester. Why? Because normally if you prepare like this, it is impossible to remember glyceric word. So glyceric esters obtained by reacting with the alpha halo esters and carbonyl compound. It may be aldehyde or ketone. Carbonyl compound may be aldehyde or ketone. Now see, this is a key point in this one, most important point. It is a CC and CO condensation reaction. CC as well as CO condensation reaction. This is a point repeated in many entrances. Only this point. Normally if you see other reactions, only CC condensation, otherwise dehydration. CC condensation followed by elimination. But CC condensation followed by CO condensation observed only in case of Darzens. If they want to ask any question, first in their mind, only this point will be appeared to ask question. So they are willing to ask. If they want to ask any Darzen question, first they will ask which among the following will give CC and CO condensation. So it is only one reaction will give CC and CO. This you need to remember. Now see this. I am taking a alpha halo ester. Is it ester? This position I am writing halogen. Is it alpha halo ester? Now it is reacting with a RC double bond OR. It may be symmetric ketone or unsymmetric ketone. Now NaOH is the ester or base. Alkoxide, hydroxide, you take any one. Now this alpha carbon carry halogen. Now what happens? See, this base will take over here, and finally see, this is alpha comma beta epoxide. This carbon is this one. This carbon, you assume this one. Now this carbon belongs to this one. Now this carbon carry two substitutions. One is R, other is R dash. Now this carbon already chlorine is present, that I removed. Then this is connected to ester. So this is the answer. So be careful. They will actually elevate ester, epoxide. They will write ester in a small words. Like this they will write. So generally you will watch only ester, epoxide, and you will think that it is only alpha comma beta simple epoxide. Alpha comma beta simple epoxides of ester is called glyceric ester. This name you remember. This molecular name is a common word, glyceric ester. Okay, now see the mechanism. Now first I am taking a base. This is COOET. Now I am using base. Just listen. So what is the charge on this alkoxide? Here partial, and this is negative. Partial positive, partial negative, ionic form. Now we know this base have a tendency to take proton from alpha carbon of ester. Now if they take proton from this carbon, what is the charge you will expect? Can I get minus or not? It is COOET, and what is this? Chlorine. Right? Now this base will take proton and remove in the form of ETOH. So this base takes proton here, you will get CH minus and Cl. Now this is on treatment with ketone or aldehyde, anyone you can take. Now this negative charge will attack here, and this will migrate out. Now this is a process where CC condensation is taking place. This carbon, there is a CC bond formation takes place. Can I write like this? CH. Now this carbon carry how many alkyls? Alkyl. Can I write O minus? Later on this also carry chlorine, and here. Can I write COOET or not? This is your first condensation between chlorine and carbon. So it is alpha carbon of ester. Now recently we got beta carbon. Okay. Later on this is SN2 reaction. SN2. Okay. So bimolecular nucleophilic substitution, this will attack exactly opposite to this carbon, and chlorine will be removed out. So after removing this chlorine, see here you may expect this kind of product. Now new CC bond, then later on already old CO bond, now it is a new CC bond. Next here followed by CH, and this is COOET. So initially this is formed first. This question also asked in exam. In Darson glyceric ester condensation, which bond is formed first? CC, CO. So first is CC bond, later on CO bond. This is initial condensation, this is secondary condensation. These two bonds you need to highlight. Clear? Now, will you predict the answer for this? C. I am writing alpha chloro ester. Now I am writing acetaldehyde CH3CHO. Like this they will give NaOET. We can take any kind of solvent here. Non-polar solvents are highly preferred. Why? Because there is no proton is required to add in next step. That's why on that time take non-polar solvent. So this is a code to identify. Remember, when base without any polar solvent is given, they want to ask only condensation reaction without addition of proton. If any proton is given, condensation followed by protonation. Means it may be either Perkin, Noivenigal, Stobie, like that. Very easy. By watching this one, you can guess what kind of question you want to ask. Alpha ester, caramel compound, base is there without any protic solvent, mean definitely it is Darzan's glycidic ester condensation. See, base is taking proton. Later on, this is attacking here, and one more time it will attack, and chlorine will be removed out. Okay, there is no choice to add one more proton within the product. So that's why these reactions are very easy to identify. Only thing is you try to remember the reactants. Finally, product. Product you try to remember in the form of glycidic ester. Now can you guess? Guess the answer and give the product. This is CH3, next C double bond O CH3, and this is the base. This is bromo COOET, benzophenone. Iodine also possible to used in this reaction, ethyl, and here we can use benzaldehyde. Give the products of the reactions. You apply the shortcut and predict the answer. This is C double bond OET. CHO NaOET THF. Like this also they will give an exam. They will write aldehyde and arrow. Base will be one of the catalytic medium that can use this. PH C double bond O CH3 NaOMe in presence of THF. Will you give answer in this one? See, which is alpha carbon? You condense alpha carbon and carbonyl carbon. These two carbons you need to condense. Okay, after condensing, write down epoxide. This is alpha carbon, this is beta. Beta to oxygen, and this is alpha. Alpha carry ester and beta carry. This is beta. Beta carry CH3. Okay, you join alpha carbon and beta carbon. This you assume as beta carbon. Clear? Which two are new bonds here? Which is first bond in this one? This is first bond. And what about next one? This is second. CCCO. Next, in this one. Can I write epoxide here? Epoxide and two methyls. Is this carbon is belongs to this one or not? Next, it is connected to ester, COOET. Will you work out remaining? Very easy. Just this you assume as alpha. It is a condensed carbon of ketone. Later on this carbon becomes beta. Okay. Now this is going to join one more time on this one. So what do you expect in this one? See, this is alpha carbon or not? Just you assume it is alpha. Alpha, beta. Beta attaches to epoxide. Now alpha carbon carry. There is a presence of ester as well as CH3, and here see. This carbon carry CH3 and phenyl. Will you work out this? Take down this as homework. Just you take down this. Work out this example. Is it ester? Cyclic ester also called lactone. Now, can I remove this halogen or not? Halogen is removed here. Next, it is connected to beta. Next, epoxide and here. And this carry phenyl like this. Is it alpha carbon or not? It is alpha. And what is this? It becomes a beta. Alpha and this is beta. First you concentrate on the concept, then you can predict the answers very easily. Here I am giving bromine and this is chlorine. COCH3 NaOET THF. What is the answer? Chloro and this is bromo. Now benzaldehyde NaOET. Will you get same answer or different answers? Always less electronegative halogen is highly preferred. Okay, less electronegative halogen is highly preferred if it is attached at alpha position. This is C double bond O. NaOMe THF. What is the answer? Coumarin questions are expected from this side. Sometimes they will give coumarin. After preparation of coumarin, they will undergo hydrogenation HBr. Then you will get this one. Then they will ask Darzen's glyceric ester condensation. This is very important molecule. So in DDQ and even in some selective reactions, I usually prepared carbosteryl, okay, coumarin type of selective compounds. So by removing double bond, they will put bromine over there. So then they will ask Darzen's glyceric ester condensation. Can I remove this halogen? After removing this halogen, this and this are get connected. Now this is which carbon? Alpha. And what about this? Beta. Condense them, convert that particular oxygen into epoxide. And beta carbon carry methyl and ethyl. Remember, see, this is a alkyl group, and here there is a presence of phenyl. Phenyl is oriented below the plane. Now this is O minus. Okay. Now here I am writing one ester, COOET, and here see, here I am writing one hydrogen. Okay. Now this alpha carbon attached here. Then later on, this particular carbon carry like this. So this carbon I am writing chlorine. Now here I am writing above the plane COOET, then below the plane hydrogen. Now this is glyceric ester condensation reaction only, but after condensation they will write a base. So they will give THF solvent, and here they will give sodium salt. Initial CC condensation. See, this O minus will attack on this alpha carbon such a way that this living group and this both are separated by 180 degrees. Anti-periplanar arrangement. So after anti-periplanar arrangement, this will attack here and this chlorine will be removed. And that will generate a proper stereochemistry. Okay, first you need to attack such a way that both these two groups are anti-periplanar. So here epox exactly perpendicular. After attacking here, this will be thick line itself. COOET thick line. And what about this? This is hydrogen. Now here this is methyl is same direction, and phenyl is also same direction. This remember. First you need to bring both alkoxy as well as this halogen. This halogen and alkoxy both should be perpendicular to each other, separated by an angle of 180. Okay. Now see, this is O minus, and this is methyl. Here see, this is dotted line. Okay. Now here see, I am writing ester. This is ester stereochemistry. Now here I written chlorine, then followed by hydrogen. Now how to participate in reaction? Can you participate directly? No. First you need to rotate this chlorine in place of ester. If you rotate this chlorine, then only what happens is this is exactly perpendicular to O minus. So this question you can expect from here directly. They will give like this in THF. They will ask what is the answer. You can expect, but they won't mention base here. Why? Because already it is a condensation intermediate. Okay. After getting this anion, this will attacks on this alpha carbon of this ester such a way that only when if chlorine is perpendicular to O minus. Now you need to rotate such a way that chlorine should be perpendicular to O minus. How to rotate? Can I rotate this bond? No. Why? Because already it is in vertical line. Okay. Now I am rotating. This is pH dotted line, and here methyl thick line. Now what about this chlorine? Can I bring chlorine from here to here or not? So if you rotate here, how much angle you rotate it? 120. So from here to here 120. So then ester goes back side or front side? Back side. Ester goes to back side. COOET. Then what about hydrogen? Hydrogen goes to above. Then that is the answer. Don't write answer from here. You try to convert first chlorine perpendicular to oxygen. Then you attack here. Then chlorine will be removed. This is called SN2. One point explain. Starting only in mechanism. Loss of halogen in glycosidic ester is a SN2 reaction. So give one example where SN2 possible means glycosidic ester, in which halogen is removed exactly perpendicular from O minus ion. Then finally whatever stereochemistry you are getting, that stereochemistry you need to write here. This kind of questions are most important. So that's why in your examination don't expect straightforward question. Exactly from middle they are asking. So by watching this, no need to confuse. Don't think it is a stereochemistry question. It is actually belongs to named reaction, but it was done in terms of stereochemical aspects. So those who know Wegen's horse model clearly, they can attempt this mode of rotation. Like this, as it is, they will give. So you work out these two examples. O minus This is phenyl and here is hydrogen. This is methyl. OET, and this is chlorine, THF. THF. Give the answer. If direct THF is given, that is intermediate reaction. Negative charge is stabilized by sodium. Write proper stereochemistry of epoxide. They will ask 4 options. In that 4 options, only the stereochemistry they will ask. So what is stereochemistry you expect here in this one? This is epoxide. Now phenyl is in dotted line. And what about methyl? Methyl is in thick line. Right? Chlorine is removed out. When chlorine is removed, hydrogen is still thick line only. Ester is in dotted line. They never changes their orientation. This is below to below, above to above only. But here actually where that is present? In vertical line with respect to this oxide. Now this is above the plane. Hydrogen is below. Now it goes to above. Like that they will frame questions with Darzens, glyceric ester. From middle it is most important. Otherwise statement question. Only 2. Will you work out this? Take down as homework. You need to rotate O minus perpendicular to halogen. Suppose if I bring this one, so phenyl goes to above side, hydrogen goes to below. Still, this we need to bring vertical. So exactly in middle, in between hydrogen and O minus ion, we need to bring vertical position. So if you rotate like this will come above, hydrogen goes backside. Okay. Now what about chlorine? If you rotate like this, chlorine vertical, this goes above, this goes below. Right, see like this it is present. See this is vertical, this is vertical, phenyl is vertical, this is above. Now what I am saying, you need to bring this is at vertical direction over here. If you rotate like this comes above. So whichever is in vertical, that will comes to above. Now this is goes to, this is above or not, already above it is. Is it above or not? What is this molecule? Atom is oxygen. If I rotate like this, this is vertical, now this is above. Who is above? Phenyl. Now in this one, already methyl is in vertical. Methyl vertical. What is this? Ester. And what is this? Chlorine. We need to bring this chlorine over here. Vertical. So this is ester. If I rotate here, still ester above or not? This chlorine vertical. Now this is above. Now methyl goes to backside. Right? So what is our target? Our target is to bring this O minus and chlorine perpendicular, separated by 180. Is it clear? This area is most important. Will you work out this? Is it okay? Practice Shapiro regularly, SN Moser also regularly. If anybody asks, you are any spontaneous way to give answer. Otherwise, impossible to attempt. Name reactions, you should be perfect. Minimum some information on every reaction. Next. Yes. Next is. Right on. Take one question. Which of the following is CC and CO condensation reaction? Which of the following is CC and CO condensation reaction? Which is CC and CO? Option A, Diels-Order reaction. Diels-Order reaction. Option B, Beckmann. Beckmann rearrangement. Now, aldol. They will give definitely aldol. Why? Because generally what is aldol? Beta hydroxy, aldehydes are not. Generally what you will think, after carbon attaches to carbonyl, double bond O converted to single bond O. Right or not? What is aldol condensation? The CH double bond O minus enolate ion will attacks on which one? Aldehyde or not? If they attacks on aldehyde, what happens? CC condensation taking place, then you will think that in your examination you will also think like this. CC condensation already taking place. Now double bond O converted to single bond O. Double bond O converted to single bond O. So this is not condensation. Condensation means attachment. Here only CC attaches together. CC attaches together but not O and C. So we are not created CO. CO already CO bond is present. So it is only a CC condensation but not CO. So definitely when Darzan's glyceric is given, they will give definitely, in order to confuse, aldol they will give. Okay, and final option is Darzan's glyceric ester. Or Darzan's reaction also they will give. Darzan's glyceric ester condensation. So which is correct? It is CSR question. Sometimes here they will give mercury. In one option they given mercury. McMurray reaction. In some examinations they are giving aldol. But remember, when they give Darzan's glyceric ester, those who know familiar with Darzan's, they will confuse with aldol. That's why they will give these two options completely. So be careful. Aldol is not CO condensation. Aldol is only CC, but not CO. This is CC as well as CO. So answer is D. Next. The major product formed in the base mediated reaction between base mediated in presence of base mediated reaction between benzophenone and ethyl chloroacetate. Like this statement they will frame. They won't give reaction, but options they will give reactions. So means you should be strong in IUPAC nomenclature. The major product formed in the base mediated reaction. It is a base mediated reaction. Okay, base mediated, many reactions are there. Okay, and they given between benzophenone and ethyl chloroacetate. Okay, now see the options. Option A. This is oxygen, and here this is C double bond O, here chlorine. Now I am giving two phenyls. Here phenyl and this is phenyl. This is option A. Now option B. This is pH, COOET. Now this is chlorine and this is OH. Chlorine and OH. Option C. pH, COOET, and this is OH and this is chlorine. Option D. pH, OET. Very easy. Right now you are in a track, that's why you can predict answer very easily. This is CSR question. (2018) CSR question for 2 marks. Very easy. The base catalyzed reaction. It is a base catalyzed reaction mediated between. So if you don't know the structure of this one, it is also a big headache for you. And one more, ethyl chloroacetate. So it is also problematic for you. So acetate means this one, remember. This is ethyl. Now here chloro is there. So now this part is acetate. Ethyl chloroacetate. We can't write chlorine other than this place. That is the option. So this structure they will give in the form of name. Clear? Clear? Right. Which of the following does not involve in Darson's condensation? Which of the following does not involve in Darson's condensation? Does not involve. CH3 C double bond O ET. Otherwise you write this one. CH2 CH3. Option B. CH3 C double bond O. Now this carry chlorine and this is CH3. Option C. CH2Cl CH2 C double bond OET. Option D all. Which of the following does not involve, I am saying? All are not involved. What is the requirement? Alpha halogen. Is there any alpha halogen here? No. Beta halogen is there. Now here? Now halogen is not present on alpha, it is present on alkyl part of ester. So here if there is a presence of halogen, no use. Why? Because it is attached to ethereal oxygen. See, this is not alpha. This is alpha. Okay, and here in this one. Alpha carbon is there, but there is no alpha halogen. Same repeat same question. Here this is CH2 C double bond O CH2 CH3. This is bromine. Option A. Option B. Here there is a presence of bromine, chlorine, C double bond O, CH2, CH3. Chlorine, bromine, iodine, COO, ET. Trimethyl COOET. All are not involved. See, is it carbon having alpha halogen? Here, alpha halogen is there, but there is no alpha hydrogen. Definitely one alpha hydrogen, one alpha halogen is required. That is mandatory. Alpha hydrogen for condensation, alpha halogen for elimination. Okay, so in this there is no alpha hydrogen, that's why there is no CC condensation. Now here remain same. And here see, first of all, there is no alpha hydrogen and alpha halogen. So all are not involved in Darson's condensation. Sometimes see, many names are there. Darson's reaction, Darson's condensation, Darson glycidic ester condensation, like that they will give. All are remain same. Clear? So that is Darson's glycidic ester condensation. Next. Riemann-Tiemann reaction, also called RTR. Riemann-Tiemann reaction. So what is RTR? So regularly I will usually say RTR only, Reamer-Tiemann reaction. Now what is Reamer-Tiemann? Remember, formulation on phenol in presence of what we are using now, chloroformine sodium hydroxide. You may use either sodium hydroxide or potassium hydroxide. So that is Reamer-Tiemann. If anybody asks what is Reamer-Tiemann means, it is a formulation reaction. First thing is formulation. So normally formulation on benzene not possible by using acylation reactions. So it is a modified form of formulations which is a deviation for normal formulation reactions. So normally formulation not possible by taking formyl chloride. If I take any Lewis acid, it cannot be survived. But formulation done by using Reamer-Tiemann, Wills-Merrick reaction, etc. Okay. Now see here, reacting molecule required a proton consisting activator. They should carry a proton. And they carry ring activator. Proton and ring activator. If there is no proton, there is no ring activator, reaction is not easily exist. Okay. Now here if I use chloroform in presence of sodium hydroxide, now maintaining 60 degrees centigrade of temperature, now you will expect mixture of two products here. Ortho and one more is para-formyl phenol. What is the name of this molecule? Suppose if I write acid here, salicylic acid. If I write aldehyde, salicyl aldehyde. Okay. Now ortho and para both are possible. This is ortho and what is this? Para. Remember, ortho is major. In these reactions, ortho is major, para is minor. You remember this. Very well known, even an intermediate student can define what is Reamer-Tiemann reaction. RTR means it is a formulation reaction. Over here we are making a formulation. CHO we are introducing. Now, whether we are creating a new CC bond or not. In this reaction, will you get a new CC bond or not? See, especially this reaction, they produce new CC bond. They produce new CC bond. And always remember, which is major? Ortho is major over para. Ortho is major over para isomer. Ortho is major over para isomer. Now, especially see, it is a EPS reaction. What is EPS? Electrophilic substitution reaction. This question also asked many times in exam. Which among the following is EPS reaction? Generally, alkylation, acylation you will think. Alkylation, acylation. Sometimes they will ask only names. On the time, RTR is a electrophilic substitution reaction. Okay. So if you take ortho is stabilized by, how ortho is stabilized? By intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Ortho is stabilized by intramolecular hydrogen bonding. That's why ortho exhibits, see, low boiling point. Low boiling point, and we can separate this by using steam distillation technique. And if you think para isomer, first you write this point, para isomer. Para is stabilized by, how it is stabilized? Para is stabilized by intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Okay. So if you compare intramolecular hydrogen bonding and intermolecular hydrogen bonding, now intermolecular hydrogen bonding will exhibit high boiling point. Okay. See, this hydrogen and this oxygen forms a hydrogen bonding. This is called intramolecular hydrogen bonding between ortho substitution. Like this, there is a hydrogen bonding formation takes place. And if you go through intermolecular, this is called intra, within the molecule, and this is inter, between the molecule. Between the molecule means, if I take oxygen here, now this is para substitution. Now this is get stabilized by hydrogen bonding. Is it para or not? Like this. So this is called intermolecular hydrogen bonding. This is very stronger as compared to this one. So if you compare between these two, the intramolecular exhibits low boiling point. Intermolecular, between the molecules, if any hydrogen bonding establishes, this bond is very stronger as compared to intra. If bond is very stronger, they liberates high boiling point, and this is low boiling point. So that's why these two isomers are separated by, this can be isolated by, remember this is a key point in this one. These two isomers are isolated by steam distillation method. Steam distillation method. This is a key point in this one. In Riemann-Tiemann reaction, two isomers are obtained, ortho and para. Between ortho and para, which is major? Ortho is major. Even though ortho is major, but ortho liberate low boiling point, para liberate high boiling point. There is no comparison between these two. Generally I am saying it will comes one more time in freeze rearrangement. Be careful, this point I will ask over there. In freeze rearrangement also, ortho and para acylated phenols will get. But there we are using aromatic ester. But here we are using only phenol. Phenol reacts with chloroform in sodium hydroxide. You will get ortho and para. Ortho stabilized by hydrogen bonding. What is it? Intramolecular. Now this is intermolecular. Okay. So this is major. It is stabilized by ortho. This is minor. It is stabilized by which one? Intermolecular. Even though it is minor, whose boiling point is very high, I am saying. Why? Because it is stabilized by strong hydrogen bonding. And due to this boiling point, we can separate based on their steam distillation technique. Steam distillation technique can separate one of the isomer which having a lowest boiling point first. Okay? Whichever molecule having lowest boiling point, it can be removed in terms of liquid by using a steam distillation. So low boiling point elutes first, later on high boiling point. So can you separate ortho and para isomers or not? So ortho para isomers are separated by which method? Steam distillation. This point is important. Low boiling point and high boiling point. If they exhibits low and high boiling point, low boiling point isomer will show low boiling point. Based on that we can elutes first. High boiling point will show high energy. In order to reach that energy, we need to supply more amount of energy. After reaching that energy, it may elute in the form of liquid. So low boiling point, low energy, high boiling point, high energy. Now, even one more, spectroscopy is there. IR spectroscopy. IR spectroscopy used to distinguish ortho and para isomers. Ortho isomers and para isomers are identified by IR spectroscopy. Distinguish means separate. You can distinguish or you can separate ortho and para isomers by IR spectroscopy. See, if ortho position is substituted by any group, okay, then which is major? Para is predominated. If ortho para two possibilities come, give priority for ortho. Suppose if at least one ortho having substitution, then give priority for para. Ortho position is substituted by any group, then give priority for para. Para position is predominated. See, this is mechanism. First I am taking chloroform. Chlorine, chlorine, chlorine. Now what I am using now? Sodium hydroxide. Hydrogen is removed out and carbon carry how many chlorines? 3 chlorines. Carbanion. Then followed by, there is a loss of chlorine atom. After loss of chlorine atom, what happens? You will get carbene. Carbene, dichlorocarbene is intermediate in this reaction. Okay, so after getting this intermediate is going to react with phenoxidine. This is a phenoxidine. Now carbon carry empty orbital and 2 electrons are there. Now this will directly attacks here with ortho position, and see this carbon carry double bond O. Now see this carbon carry 2 chlorine and bearing negative charge, and here hydrogen atom is present or not. Now the key step in this one is, now this particular carbanion takes proton from water. It is a solvent used in RTR reaction. Riemann-Tiemann reaction, we are using one solvent. That solvent is H2O. This will be added on this position. So after adding over here, now what do you expect? Chlorine and here hydrogen. This hydrogen belongs to solvent hydrogen. Be careful, this question they will ask. Now here already double bond is present, and what is this? Hydrogen is present. This hydrogen is already existing position of ortho. This hydrogen is must. If this position, if hydrogen is not there, you cannot bring back phenol. Okay, now this hydrogen come back here and this will migrate out. This is called tautomerism. Tautomerism leads to double bond, and see this is OH and this carbon carry chlorine and here hydrogen. Now this is benzyl position or not? Benzyl position further reacted by OH minus ion. Okay, back to back it is possible to react here, and this is removed out. So repeat 2 times here. 2 times SN1 reaction. It is SN1 reaction how many times? 2 times. So every chlorine atom is removed by OH atoms. After removing OH, then see this carry OH and here OH. Now one carbon carry 2 OH undergo dehydration. So after dehydration you may expect formyl group at this place. This is OH and this is C double bond OH. That is the answer. Clear? Then, so what is the reaction intermediate? Reaction intermediate is dichlorocarbene. Otherwise you write simply carbene. So this is most important point. Dichlorocarbene is reaction intermediate in this one. Otherwise simply carbene. Carbene intermediate name reaction is Riemann-Tiemann. Okay. Attacking nucleophile. So which is attacking nucleophile? Attacking nucleophile is phenoxide ion. Attacking nucleophile is phenoxide ion. Okay. See, product of this reaction gives positive 2,4 DNP test. Positive 2,4 DNP test. Remember, DNP test only for carbonyl compound. Initially they won't give DNP test. After getting product is giving 2,4 DNP test, means definitely there is a formation of carbonyl. So product of this reaction give 2,4 DNP. What is DNP? Dinitrophenyl hydrazone. Hydrazine converted to hydrazone. So DNP test, yellow orange crystals are going to be appeared while reacting with a carbonyl compound. Reactant will not give DNP, but product will give DNP test. Phenoxide ion is attacking group on electrophile. Who is electrophile here? Carbene. This electrophile is substituting on benzene. So that benzene should carry electron activator. So indirectly I am saying that C, electron releasing groups increases rate of reaction and electron withdrawing groups decreases rate of reaction. So what we are substituting? We are substituting electrophile or not? When electrophile is approaching, what kind of character is required for benzene? Benzene should carry more electrons. So that's why releasing groups on phenol decrease reactivity, withdrawing groups on phenol decrease reactivity, releasing groups on phenol increase reactivity for Riemann-Tiemann. This point you can expect in your exam. Which among the following is more reactive in Riemann-Tiemann, like that. So Riemann-Tiemann is electrophilic substitution. Electrophile is coming to benzene. When electrophile is coming to benzene, benzene should carry more electrons. Which group will increase more electrons? Releasing groups. That's it. See here. Anisole aniline. Anisole aniline does not involve in reaction. Does not involve in reaction. So Riemann-Tiemann reaction not possible for anisole and aniline. Why? Because anisole carry, there is no presence of acidic hydrogen. What is anisole? Methoxybenzene. Methoxybenzene is called anisole. This anisole not having any acidic hydrogen, that's why this is not going to react in Riemann-Tiemann. What is the requirement for Riemann-Tiemann? Hydroxy. Okay, definitely one proton is required on high electronegative atom, which will increase electron density on benzene. Now I am taking aniline. Aniline carry lone pair of electrons and they carry two hydrogens. Aniline. When aniline reacts with chloroformine sodium hydroxide, so what is the answer? Your answer is not acylation, your answer is isocyanate. This is most important, many times asked in GATE exam. This point. By watching this molecule, you will think always Riemann-Tiemann only. Chloroform sodium hydroxide, chloroform in potassium hydroxide. But when aniline reacts here, you will get a isocyanate. What is the reaction? Carbyl amine reaction. Carbyl amine test. What is this? Carbyl amine test or carbyl amine reaction. Carbyl amine reaction. Named reaction it is. Isocyanates also called carbyl amine. When not only aromatic, even aliphatic also will give this foul smell, rotten egg smell. You won't stay in laboratory if this reaction is passed. Okay, so you will get tears and smell will be uncontrollable. That is called carbylamine test. Test for isocyanate is called carbylamine test. Now same phenol I am giving, but in place of chloroform I am using carbon tetrachloride in sodium hydroxide. What is the answer? In place of phenol, chloroform in sodium hydroxide, now I am taking phenol, carbon tetrachloride in sodium hydroxide. When two chlorines are there, how many times you are substituted? 2 times. Now one chlorine already we removed, 3 chlorines are present. Write down 3 times, remove 2 times hydroxy, then you will get 2 times responsible to give C double bond. One is as it is, that is carboxylic acid. If CCl4 sodium hydroxide is given, if chloroform sodium hydroxide is given, remain timine. CCl4 sodium hydroxide is given, salicylic acid. Still ortho is major. Okay, be careful. I am not writing CHCl3. I am writing CCl4. CBr4. You can take any one. Carbon bearing with 4 chlorines or 4 bromines under alkali medium will give salicylic acid. So aniline reacts with chloroform and sodium hydroxide gives phenyl isocyanate. That reaction is called carbylamine reaction. It is a name reaction. Remember, carbylamine reaction nothing but, if you know remain timine, no need to learn carbylamine reaction. Both are same, but in place of phenol we are writing aniline. Even aliphatic amines also possible. That will give a rotten smell, rotten egg smell. If you do experiment in ground floor, you can easily go out from 3rd floor. Not only from ground floor, from 3rd floor you will vacate that place. That much uncontrollable smell will be here. And students will suffer from headache even, and eyes will be completely closed up. And tears will come continuously. Why? Because that smell will be there for 1 week. Even if you sleep continuously, throughout the night, your body feel the sensation of that smell. So that's why most of the laboratories they won't permit to do without any faculty. Now see this, can you give the product for this? Here I am giving OH and this is CH3. Chloroform in sodium hydroxide. What is the answer? I am giving, what is the name of this molecule below one? Alpha naphthol. This is called beta naphthol. What is the answer? Chloroform in sodium hydroxide, what is the answer? So what is the name of this heterocyclic ring? Chloroform in sodium hydroxide. What is the name of this? Pyrrole. Okay. So pyrrole is most important in EPS, one of the stronger molecule to participate in this one. You will get this one. Formylation takes place at 2nd position. And here a miscellaneous product is going to be appeared as a minor. That is called, you remember this name. 1, 2, 3. This they are asking every time. Abnormal remain-timine, ring expansion product. But which is major? This is major only. Still this is major. So this is called normal RTR, remain-timine reaction, and this is found to be minor. But see, this is called abnormal. Abnormal RTR. What is abnormal RTR? Abnormal RTR means, so whose conditions are not suitable, but we are getting product here. So this is minor. Some questions they will ask such a way that your reaction will not proceed with this. They will proceed with abnormal conditions only. So whatever conditions you are maintaining, that conditions are abnormal for this one. That's why it is called abnormal remaintainment. Still major is this one, which is a preferred position for EPS. This one. Okay? And if I take furan involved in remaintainment, what is the answer? Thiophene involved in remaintainment. What is the answer? You know pyridine? Pyridine involved in remaintainment. What is the answer? So where you will make formulation? In this one. Para position. Here you make formulation. Write CHO. You should write like this. Will you write? Here OH, CH3 and what is this? CHO. After getting remaintainment, one exception reaction is there to prepare catechol. Peroxide rearrangement. Dakin rearrangement. Name is Dakin rearrangement. So if they ask RTR, next they will ask Dakin rearrangement. In rearrangements I will explain. Now, where you will make formulation? Beta. Beta position. Now, alpha. Here you said. Now here, gamma. Here you substitute formyl. Okay. Now here, where you will substitute? At para. Okay. Now in this one, where you will substitute? Second position, third position. So pyridine is highly inert in remaintainment, not easy to participate. Why? Because pyridine is electron deficient ring. High temperature is required to participate this one. So if you maintain high temperature with a low yield, it is possible to give remaintainment. But this is not excellent reaction, very poor yield. Why? Because already suffering from electron density and you are substituting one more electrophile. So what is the use? No use. So what is the name of this molecule? Indole. Indole involved in remaintainment reaction where you will make formulation. Formulation, be careful. Formulation will take place on third position. Be careful. This is very, very important one both for RTR and Wheels-Meyer-Heck reaction. This is regularly they are asking. Why? Because normal 5-member ring second position. But 5-member present in benzene, if it is fused, then whose place is third. And this is exception in case of benzobifuran. Suppose if I give benzobifuran, this is benzobifuran. Same composition, your answer is still second position. In case of benzobifuran, it is exception. But benzo C or benzo B thiophene is approximately equal to indole. Chloroform in this one. Now you may expect this product. This is OH and this is OH3. This is called guaiacol. When guaiacol reacts with chloroformine sodium hydroxide, what is the answer? This is OH and this is OH. Chloroformine sodium hydroxide. Exactly. One ortho position is free. So we can say here you will expect this answer. If 2-hydroxy given, you can take any one as a reference. Okay. Now this is on treatment with diiodomethane in presence of sodium hydroxide. Now two hydrogens, two iodines are get removed out and this is going to be introduced in between them. Now you may expect O attaches to CH2, it is attaches to O and this is CHO. What is this? Piperonal. Where we prepared piperonal? Neuvenigal rearrangement. See. What will expect here? OCH3. Can I write formyl group here? This is vanillin. Vanillin. Guaiacol to vanillin. Piperonal. This is called piperonal. Then it is further involved in Neuvenigal reaction by taking active methylene group in base. Suppose if ortho para positions of phenol is substituted by alkyl group, there is no availability of proton. So what is the requirement of Riemann-Tiemann reaction? There is a requirement of proton or not? If proton is not available, remember this will direct at ortho position. First priority, it will direct at ortho position. Okay, so you will get C double bond, methyl and methyl. There is no hydrogen and it will be developed CH2, Cl2. CH, Cl2. There is no further tautomerism. Reaction stops here only. Okay, so molecule will not attain aromaticity. Why? Because there is absence of proton. Dichloromethane is your final answer. formulation will takes here, and one more product is expected here now. This is C double bond O, double bond, and hydrogen is not there, so expect CH, Cl2. It is also possible, but this is minor. It is minor possible, but this is major. So what is intermediate in Riemann-Tiemann reaction? Dichlorocarbene. Now that dichlorocarbene is going to react with pyrrole. So after reacting with this one, see this electron going to trap this carbon. After trapping, you may get this molecule. Here hydrogen, carbon, how many chlorines are there? Chlorine, chlorine. This is key intermediate. Now this is helps to prepare variable products. Remember, abnormal Riemann-Tiemann is saying that this will migrate here and this will transfer out and chlorine is removed out. So if you remove chlorine, then what is the answer? This hydrogen, chlorine is removed out. After removing this, how many member ring you will expect? You will expect a 6-member ring, double bond, and third position carry chlorine. This is one process. So same molecule when they combine together, you will expect this intermediate. Here double bond, and here 2 chlorines are present like this. Okay, so this bond migrate here, this will migrate here, and this will transfer out. So after transferring this carbon carry negative charge or not? So this is going to get double bond, and see this carry chlorine, chlorine. I am adding direct hydrogen from solvent, direct step I am writing. Why? Because this proton is always solvent proton. Then later on this hydrogen migrated. Now this is tautomerism. After tautomerism, what will you expect? After tautomerism, hydrogen is present on nitrogen. This carbon carry 2 chlorines and 1 hydrogen. So reacts with OH minus of reagent. That will give direct answer I am writing. Dehydration of 2 alcohols will give formyl group. That is the answer. So formylation at second position, ring expansion over here. So 2 are possible, but this is called abnormal mechanism. Electron rich becomes electron deficient. But here electron rich still electron rich only. So that's why this is a abnormal RTR. This is not a preferred reaction, abnormal RTR, and it is a preferred RTR. In reactant intermediates, this mechanism already given. Carbene intermediate, ring expansion with 5-membered. Right. Take one question. The abnormal RTR, riemann reaction product in following. Chloroform in sodium hydroxide. What is abnormal product? Option A. B. Which is abnormal RTR? Answer is D. If they mention abnormal, then only you write this one. Otherwise, normal, which is correct answer? What is RTR product? B only. Which of the following is highly reactive in RTR, riemann reaction? Option A. Phenol with cyano, phenol with methyl. Option D. Phenol with nitro. Which of the following is highly reactive in RTR? Which is more reactive? A is correct. Electron releasing groups increases rate of reaction. Withdrawing groups decreases rate of reaction. Methyl and this is first, this is second. So between nitro and cyano, which is a strong withdrawing group? Nitro. Then later on this one, later on this one. So what is the requirement? Definitely proton is required. Acidic hydrogen is required. Then it is participates in RTR. Now, which of the following is does not involve in Riemann-Tiemann reaction? Which of the following does not involve in Riemann-Tiemann reaction? This is OCH3, B, cyano, C, aniline. Option D, all. Which is not involved in RTR? All are not involved. See, the correct order of reactivity in RTR is, the correct order of reactivity in RTR is, what is the correct order of reactivity in RTR? This is 1, 2, 3 and this is 4. So no options, write the answer. The correct order of reactivity in RTR. Riemann-Tiemann reaction, write the correct order of reactivity. Which is more reactive? First one is more reactive, then. First one is more reactive than third one. Third one is more reactive than fourth one. Fourth one is more reactive than second one. Pyridine is highly inert. Okay, so here see, in pyrrole, due to presence of lone pair of electron, ring is electron rich and molecule having acidic hydrogen, so they have a tendency to lose proton and involve in Riemann-Tiemann. So we know electron rich heterocyclic rings are more reactive in EPS as compared to electron deficient. Clear? Next. Wheels-Mayer-Heck reaction. Some books they will write as HAEK directly, that is also acceptable. Wheels-Mayer-Heck reaction. HEACK also they will write. So different countries they will use different fonts. So all are acceptable, you can write any one. So but name is remains same. Wheels-Mayer-Heck reaction. So what is Wheels-Mayer? Is it similar to Riemann-Tiemann or not? Yes. Formulation on aromatic rings. Formulation of aromatic rings by using DMF in POCl3. DMF in POCl3. Formulation on aromatic ring by using DMF in POCl3 is known as Wheels-Mayer-Heck reaction. So Riemann-Tiemann and Wheels-Mayer-Heck both are formulation reactions. This point you remember. So we can make formulation on benzene or any aromatic system. Okay. Normally there is no specific requirement of electron releasing groups in this one. Now if I take any dimethyl formamide, so most commonly they will give like this, POCl3 in presence of DMF. Then what is your answer? Answer is there is a formulation on benzene. Suppose if I take any aromatic ring which having electron releasing groups, this reaction is still possible. It is simple a formulation reaction. Okay, in this case also ortho is predominant. Here it is OH, ortho is major, para is minor. This is OH and this is CHO. So always ortho is major in this reaction and minor in case of para. So in case of Riemann-Tiemann reaction, there is a requirement of acidic hydrogen, but there is no requirement of acidic hydrogen here. Donor withdrawing group all can participate in this reaction. Aromatic system carry any electron withdrawing group have a tendency to participate, but reaction is dead slow. POCl3 in presence of DMF, dimethyl formamide, your answer is metaformylation. So yield is very poor here now, metaformylation. So very low percentage of yield, low percentage of yield. What is DMF? Nitrogen carry how many methyls? 2 methyls are there. And this nitrogen adjacent, there is a formyl group is present. So this formyl group will be inserted here. This is called NN, N, N dimethyl formamide. NN dimethyl formamide. NN dimethyl formamide is called DMF. Wheels-Meyer-Heck reaction is a formylation reaction. Similar to Riemann-Tiemann, it can make formylation, but there is no requirement of acidic hydrogen. Still ortho is major in this one. And here also remains same. Electron releasing groups increases, rate of reaction. POCl3 in DMF, that reagent you remember. Okay? And especially they are highly preferred in heterocyclic reactions. See, if I take this molecule, they will give like this. POCl3 in presence of DMF. Can you write the answer? Right product for even furan, right product for thiophene. Same reactions, only thing is change in reagent. This question asked in CSR exam by giving indole. Indole reacts with POCl3. POCl3 in presence of DMF. What is the answer? Indole. POCl3 in DMF. So pyridine is highly inert in this one. POCl3 in DMF, it is highly inert. Position is 3, but highly inert in DMF. NN dimethyl formamide. It is one of the formulating agent on any aromatic systems in presence of POCl3. Phosphoryl trichloride, and that will make formylation over here. Can I make it second? Write formyl here. Now, formyl. Second position formyl. Now here, can I write third? This is asked in CSR exam, this question. With Wheels-Meyer-Heck only, they are asking regularly. Followed by, they are asking gramine preparation. Where we prepared gramine? I think somewhere you listen that word. Why? Because I am continuously shouting. Gramine, gramine like that. Mannish reaction. Tutocane, paraconic acid. Paraconic acid we not prepared in that one, but we can prepare tropine, tropinone, tropic acid. Okay, later on decomposition, hydrogenation reaction. Then we prepared gramine, and amino acids also we prepared. Anesthesia one, anesthetic drug also we prepared on that one. That is called tutocane. So where you will make formylation? Second. Now sulfur is here, third. Now here. Third position, but yield is very poor. It is not acceptable. Formylation on pyridine is not acceptable. Why? Because pyridine itself, it is an electron deficient heterocyclic ring. Indolizine. Is it aromatic? Indolysine. Indolysine is aromatic. So where you will make formulation? Indolysine. If this position is covered by methyl, POCl3 in presence of DMF. What is your answer? So here you add formyl group in this one. Now here you add very closer to nitrogen. These positions you need to remember. DMF is very important reagent. Remember, POCl3 and DMF they will ask regularly. Mechanism of this reaction. So here I am saying nitrogen attaches to methyl. Is it a amine or amide? Is it a amine or amide? Amine. Having how many lone pair of electron? One lone pair of electron. It is going to combine with a carboxylic acid. So what is the name of this carboxylic acid? Formic acid. Now it is on treatment with a toluene. Toluene reflux. When acid plus amine undergo reflux conditions, helps to make a dehydration. So there is a loss of water molecule from this, and see there is a formation of DMF. Now there is a formation of amide, C double bond O H, and see this is preparation. Sometimes this preparation of amide they will give dimethyl formamide. Now after dimethyl formamide, now it is going to react with POCl3. Okay. Now this lone pair of electron will migrate here, and this oxygen will get negative charge. I am writing one of the resonating structure. This is nitrogen carbon double bond, carry negative hydrogen, and you can write methyl, and here one more methyl. Then you write down POCl3. 3 chlorines are attached here now. So this will attack on this, and oxygen carry negative. So after getting negative charge, then what you will expect? Carbon nitrogen double bond, O attaches to phosphorus, O minus. How many chlorines are there? 3 chlorines. And here hydrogen, next this plus, and here methyl, and this is methyl. Okay. Now this negative charge come back here, and this chlorine attacks here, and this will transfer to oxygen. Okay. So after transferring, you will get one intermediate now. Okay. Nitrogen carry double bond with carbon, and see this carry methyl, and here also methyl is present. It carry one chlorine, and this is hydrogen. So this is intermediate you need to identify in Wheels-Mayr-Hake. In your Wheels-Mayr-Hake reaction, they won't give complete molecule, they will give this as a middle, and this is get stabilized by a negative partner. Who is that negative partner? P double bond O, which carry O minus, chlorine, chlorine. This mixture they will give sometimes in your exam. No need to confuse if they given this mixture. Okay. So later on, see, this is combined with any aromatic system. Okay. I am taking one aromatic system like this. Suppose if it is a anisole. Now here lone pair of electron is present. This will migrate here. This will attaches to this carbon, and this will migrate to this one. So actually nitrogen carry positive charge. Can I? So after this, what is the answer? There is a double bond establishes between oxygen and carbon. Then this is attaches to carbon with chlorine, hydrogen. It is attaches to nitrogen with methyl and methyl. Okay. Later on, due to tautomerism, this hydrogen will be removed out. So shift of proton will take place. So there is loss of hydrogen will takes. Tautomerism followed by loss of proton. Now this is OCS3. Remove that proton and you can use this. So now this is chlorine and nitrogen. Nitrogen carry how many methyls? 2 methyls are there. Then use aqueous medium. DMF means we can use aqueous medium clearly. After using aqueous medium, this can attack this carbon 2 times. Chlorine is removed, nitrogen is also removed in the form of living group. Finally 2-hydroxy will come. The 2-hydroxy undergo dehydration and you may expect formaldehyde or not. This is formaldehyde, that is the answer. Now key intermediate is this one only. In your examination this they will write. And this is also most important one step. Here hydrogen is removed. This is not initial tautomerism. When you remove this hydrogen, there is a loss of proton will takes place and the sigma electron stabilize this one. So this is called source which is helps to attain aromaticity. Driving force to helps aromaticity. So loss of hydrogen takes place, but it is not tautomerism. So here you need to remember this point. This molecule, if you remember, it may helps in your exam. The electrophile involved in Wheels-May-Reck reaction is chloroiminiums. So these two they will give, then they will give water like this. Don't confuse. By watching that bulk molecule, don't think that a new product is going to be obtained. It is an intermediate absorbed in Wheels-May-Reck reaction. This you need to remember. While you are writing short notes, Wheels-May-Reck reaction is a formylation reaction. Reagent is DMF POCl3. Then intermediate is this one. These two you write down at one place. At least you need to remember this intermediate. It is looks like a mannish intermediate or not? Looks like mannish intermediate? Yes. In mannish reaction, what is intermediate? Iminium. Iminium attacked by enol or enolate? Enol. But here iminium attacked by aromatic system. That is the difference. Like that you need to compare. One reaction to other reaction, if you compare the difference, then you can remember very easily. POCl3 they are asking regularly even for pyridine even. Most important reagent for pyridine. For alpha chlorination of pyridine, POCl3 will be used to displace the halogen. So that is end of Wheels-May-Reck reaction. Over. So Wheels-May-Reck is over. So tomorrow you will see other name reactions. We'll stop here. We'll continue tomorrow. So morning schedule is remain same, 9:30 to 12:30. You have photochemistry class. So in middle I will take some pericyclic questions. So evening schedule also remains same. Tomorrow evening also same schedule. Whatever we are following today, same schedule will be repeated tomorrow. Okay, we'll stop here. No inorganic class, you can leave now.